Hello everyone, welcome back to my YouTube channel. Today we are going to see the Maharashtra State Board Class 10 Science 2 Chapter number 9 Carbon Compounds, and this is the part 2 of the video. In the first part already we have discussed about the carbon as an atom, its nature and why it is called as the versatile element, and along with that some basic part of the hydrocarbons we have discussed. In that, the bond formations, the property of the carbon called as the catenation, hydrocarbons, saturated hydrocarbons, unsaturated hydrocarbons, branched carbon atom or the carbon compounds, then the ring carbon compounds. This all we have discussed. So in that, we are just going to add one more thing and the one new word which we called as the isomeric compounds. Now the question comes, what is this isomeric compounds? When we talk about the carbon compounds, we have a huge list of the carbon compounds. And as we know that carbon is having its important characteristics which we call as the catenation. And with the help of this, carbon can make a long chain of the carbon atoms. In that case, here if we will consider this two structures. When we talk about these two structures, the formula is the same, that is C4H10, but it can be written in a different way. Here, if I am talking about the carbon atoms, they are in a one single straight chain, whereas here three are in a straight chain and one carbon is in a branched form. So in this particular case, when we talk about this branched chain, then the concept of isomeric comes. Isomeric means the compounds have the same molecular formula but the different structural formula. Here you can see this both are having the same molecular formula, that is C4H10, but their structural formula is different. So this kind of compounds are called as the isomeric compounds. Further, when we talk about the next part, that is the ring structure of the cyclohexane. This is a cyclohexane. Why cyclohexane? Because it's forming the complete cycle of the 6 carbon atoms. And that's why the cyclic, because of that complete round structure and 6 carbon atoms, that's why the hexane. And the two remaining valencies of the each carbon is filled by the two different hydrogen atoms. Further, as some more saturated and unsaturated hydrocarbons they have given is a straight chain hydrocarbons, here the propane, here propene and propyne. Further is a branch chain hydrocarbons, that is the isobutane and the isobutylene. Further is a cyclic hydrocarbons, that is the cyclohexane, cycloheptane, here cyclohexene, and this is the benzene. So this is nothing but what is about the various types of the hydrocarbons. Now the next concept what we have to study, that is the functional groups in carbon compounds. Now what is this functional groups? As we have studied that carbon compounds, they are having the hydrogen attached to the carbons. In that case, one of the hydrogen is replaced by the another element or the group of elements, and that group of elements is called as the functional group, or that particular element is called as the functional group, and that forms the list of carbon compounds with that particular functional group, and that is also under the category of the organic compounds. Let's see the examples here. When we talk about the different functional group, you can see over here for the halogens we use the name as the halo, then the alcohol, aldehyde, ketone, carboxylic acid, ether, ester, amines, like that different list we have, or the long list we have for it. And then the structural formula, you can see the structural formula for the each functional group they have given. Like for the halogens we are using the X, in that chlorine, bromine, iodine, all are there. Then the OH is there, that is a condensed form. Then this is structural formula for the functional group, and CHO, CO, COOH for the carboxylic acid. Then the ether, that is the oxygen, is linked in that. Then COO is for the ester, NH2 is for the amines. Now here what the series they are forming by replacing one of the hydrogen in the given hydrocarbon, that is called as the homologous series. Example I am taking, like if I am having the CH4, C2, H6, C3, H8. In this, one of the hydrogen is replaced by the alcohol group. So this will become CH3OH. Here this will become C2H5OH. It will form C3H7OH. So like this the list will form for the alcohols. This is called as the methyl alcohol, ethyl alcohol, propyl alcohol. Like this it will form the long list. So this is called as the homologous series. Like that, for the each functional group there is a homologous series. Further, the next when we talk about is the homologous series of alkanes. You can see over here for the methane, ethane, propane, butane, pentane and the hexane. And here their boiling points they have mentioned, number of CH2 units and the number of carbon atoms they have given. Further is a homologous series of alcohols. You can see just now I talked about this, so you can complete this table according to that. Same with the homologous series of the alkenes, also they have given ethene, propene, 1-butene and the 1-pentene. Further is they have given or they have talked about the nomenclature system of the carbon compounds. System of common names, how to give the names to this particular structure. Here, initially when the number of known carbon compounds was small, scientists named them in a variety of ways, but that is not possible because the carbon is having a huge list of the carbon compounds, as already we have discussed in the previous video. So for that the one specific system was required, and that we call as the IUPAC, the International Union of Pure and Applied Chemistry, that gave the proper concept of the nomenclature for the carbon compounds. In that, this particular IUPAC, when we talk about, is accepted all over the world. IUPAC names and this common names, how they are, let's see. In that we have a certain things, that is a parent, suffix and the prefix. They are arranged in the name as follows, that is the prefix, then the parent and then the suffix. Let's see over here is about, first we will understand about the parent names. Structural formula: CH3, CH2, CH3, straight chain, that is a 3 carbon atoms. That's why the parent name is a propane. So it depends on the particular carbon compound how many carbons are present in a straight chain. According to that the name will be decided for the parent. So here only 2 are there, so it is a ethane. 3 are there, so propane. 4 are there, so butane. 3 are there but with a 1 double bond, so it will be called as a propene. With a 1 triple bond it will be called as a propine. So first of all we have to select the longest straight chain of carbon. That we have to keep in mind, and we have to give a lowest number to the functional group or the double or triple bond. Step 2 is the structural formula consists of a functional group. Replace the last letter E from the parent name by the condensed name of the functional group as a suffix. Like if alcohols are attached, then it will be E or the of the alkane or the alkyne will be replaced by OL. And if it is a halogen, then it is attached as a prefix. Step number 3, there is a number of carbon atoms in a carbon chain. From one end to the other, assign the number in 2 directions, except the numbering which gives a smaller number to the carbon carrying the functional group. In this, if I want to talk about this, suppose if I'm having a carbon chain like this, and here bromine is attached, one of the halogen. So two ways are there to number it. The one is 1, 2, 3, 4. Another way to number it as a 1, 2, 3 and 4. So we will accept the first case. This will be accepted, not this. Why? Because from this 2 is a number for the bromine, and from this 3 is a number, so we have to select the smaller number. So first case will be accepted. Further, they have given over here as a name for it, for the different one, for the condensed name as alcohol, chloro, bromo, aldehyde, then the OIC acid, that is a carboxylic acid, then the amine and the ketone. Like this they have given, so this table we can complete. Further, they have given us some names over here for the structural formula, IUPAC nomenclature. Structural formula they have mentioned over here. You can see structural formula, two numberings of the carbon atoms, acceptable numbering, and the IUPAC name of the compound. This all they have given under this particular table. The further is the IUPAC name for this you have to write. This is your activity. Activity number 2 of this chapter, which you have to complete and you have to send back to me. Further is chemical reactions or the chemical properties of the carbon compounds, which we will see in the next video.